Okay, now, Nina, recall back your redox. What is redox now?
Oxidation and reduction happen simultaneously.
Oxidation and reduction happen simultaneously. What else?
The oil rig when oil rig.
Okay. Oxidation as what? Recall back.
When you lose electron.
Gaining or losing electrons, right? Gaining or losing electron. Now, what else?
Oxidation state increase when there's oxygen. Decrease oxygen.
Oxidation state, either increase in oxidation state or
decrease.
Oxidation is increase in oxidation state. Reduction is decrease in
oxidation state.
Oxidation state, right? Okay. What else? What else do you remember?
The ionic equation.
Ionic equation, yes. Malisa, you okay with ionic equation now? Malisa, you okay with ionic equation? Okay.
But I still need to do some more.
You need to do some more. Okay, I tell you what, I'll get Amar to email you, or I write down a few and then get Amar to send it to you and then you do it, okay? You have to practice.
Okay.
You're very good with it. Okay, so we discussed about oxidation. Oxidation as in increase in oxygen, gaining of oxygen, like magnesium plus oxygen to give you magnesium oxide. That will be oxidation, right? And reduction as release of oxygen, like what? You have carbon plus copper dioxide to give you copper and oxygen, right? So copper dioxide undergo reduction. Or you can talk in terms of oxidation state. Oxidation is increase on oxidation state, reduction is decrease in oxidation state. Like magnesium from 0 to +2 undergo oxidation, +2, copper 2 to copper is reduction. Then we talk about so for it to qualify as a redox, oxidation reduction happens simultaneously, meaning that losing and gaining of oxygen happens simultaneously, increase and decrease in oxidation state happens simultaneously, losing and gaining of electron happens simultaneously. And you have your what? Oxidant undergo reduction and reductant undergo oxidation. And we discussed about a few things, right? With like sodium plus chlorine. Everyone okay with this so far? Ina, Amin, Balkis, Malisa?
Yes.
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 Right. Okay. Now, so you have to be good with this ionic equation. Okay, Malisa, practice some more. Okay. And then last class we talked about reactivity series, and then we talked about metal displacement. We talked about metal extraction. Right. So when we talk about reactivity series, recall back. Reactivity series is about tendency of metal to lose electrons. The more reactive the metal is, the greater the tendency to lose electron, right? And then you can see that in metal displacement, you can see it in metal extraction, right?
Wow.
Okay. And then you want to know what else we did. We talk about the position of carbon between aluminum and zinc. So those above carbon, how do you extract those above carbon, Marisa?
Electrolysis.
Electrolysis, right? Those below carbon, reduction with carbon. Right? And you have to know the example of it, like iron, zinc, and all those. Okay, Balkis, Malisa, are you okay with your blast furnace now?
Yes.
Yes. Okay. No what happened in blast furnace. And then we discussed about electrolysis of aluminium as in bauxite, right? Now, are you have you tried? Did you complete the question I give you? Yeah, the one on titanium and everything. Dah belum, Balkis?
Dah nak habis.
Dah nak habis. Nina, dah
Tak complete.
The first one.
The one on extraction, metal extraction.
Yes.
Okay, now when we discuss this, remember I said what? We will be looking at redox, overall redox, right? we'll be looking at redox from what? From when you talk about redox, reactivity series, we are done with displacement reaction, we are done with metal extraction, we are done with, you are left with rusting and all those. And then today you'll be doing your electrochemistry as in simple cell, Daniel cell. Okay, your next class will do rusting and prevention of rust. Okay, but when we do all this, you have to look at it from the perspective of redox, from the perspective of increase and decrease in oxidation state, from the perspective of losing and gaining of electron. Okay, now let's do this. Recall back. What do you know about electrochemistry, Balkis?
Voltaic cell, simple cell.
Yeah, voltaic cell. Is voltaic cell electrolysis?
Yes.
Voltaic cell is not electrolysis. Okay. Now, afterwards, pay attention and look what is voltaic cell. What else do you know? Okay. But when you do electrochemistry, you will be doing voltaic cell. What else?
Daniel cell.
Daniel cell, yes. What else?
Simple cell.
Simple cell, which is voltaic cell. What else? What else? You have anode, you have cathode, you have electrolyte, you have electrode. Remember?
Yeah.
Yes. Okay. Now, Melissa, what do you know about electrolysis? Electrochemistry? Melissa? I mean, what do you remember about electrochemistry?
There's electrodes, electroplating.
Nina, what do you remember about about electrochemistry?
The aqueous solution, the molten solution.
Electrolysis.
Yeah.
Now, so when you talk about electrochemistry, you're talking about later, we will talk about electrolysis. We'll talk about voltaic cell. And we'll talk about the
Daniel
cell. And then we will recap back a little bit. Now start with the electrolysis. When you talk about electrolysis, okay, Junitri, someone Junitri, can you mute your mic? Okay. Now you have this, say, right. So when you have when you do electrolysis, you have your electrolytic cell. You have your electrodes. What are these electrodes made up of?
Carbon, graphite.
Graphite. Okay.
and platinum.
Graphite,
Platinum.
okay, now explain why graphite can be used as electrodes. Explain why graphite can be used as electrodes. Why graphite can be used as electrodes? Balkis, why graphite can be used as electrodes?
It can conduct electricity.
Yeah, but what make it able to conduct electricity?
The movement of ions.
Is there ions in graphite?
No.
What makes graphite able
Very
to conduct electricity? Okay, Nina, what make it possible for graphite to conduct electricity?
They are the localized electron.
Localized electron. Kenapa? Describe graphite.
hexagonal layers
It's made up of
of
Hexagonal
carbon
layers.
arranged in hexagonal.
bonded to 3 other carbon in a hexagonal layer. So therefore, Loti, can you get to mute themselves? Okay, thank you. Okay, so graphite is 1 carbon covalently bonded to 3 other carbon in a hexagonal layers, right? So therefore, carbon is group berapa, Balkis?
Carbon.
Carbon
Group
group,
berapa? Carbon.
kamu group berapa? Vanessa, carbon group berapa? Carbon is in, Nina, carbon
Group 4.
group 4. How many valence
Yeah.
electrons?
4 valence
So
electrons.
in graphite, 1 graphite covalently bonded to 3 other graphite in hexagonal layers, meaning we have 1 delocalized electrons.
1
My
delocalized.
question to you just now, Balkis, I asked you, what make graphite and electrodes? Reason is because there is delocalized electron between the layers of graphite. So graphite can conduct electricity, right? So now,
Yeah.
why you use graphite and platinum? I mean, what do you call this graphite and platinum?
Inert electrons.
Yes, there are inert electrodes, right? What do you mean by inert electrodes?
They do not take part in the. They do not take part in the chemical reaction in
They do not
electrolysis.
react with the
Electrolyte.
right? Okay, and the electrodes can also be any metal. What makes metal a good conductor of electricity? Balkis,
Yes.
what makes metal a good conductor of electricity?
High reactivity.
High reactivity. I mean, why metal is a good conductor of electricity? I mean,
Because there are delocalized electrons.
Yeah.
Electrons
because they have delocalized electron in the metallic lattice.
in the metal.
Metal electrons.
Remember,
Okay.
okay? So Balkis, you have to know why. Now you have electrodes, and then you have here you have the electrolyte. Right, electrolyte can be either acid or alkali or molten or aqueous ionic compound. Right, okay. Now why molten or aqueous, Nina? Nina, why molten or aqueous? In solid,
Free moving.
we
There are
have
free ions.
three.
Free moving ion.
All these have free moving ions. Why is it sodium chloride cannot conduct electricity in solid? Because
The ions are held together by
ions are held together in an ionic
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 lattice.
lattice.
lattice. There's no free moving ions. Ions are in an ionic lattice, right? Okay, so you know you have electrolyte, and then you have your electrodes, and you have to have a source of electricity. Because when you talk about electrolysis, you see the battery. So electrolysis is from electrical energy into chemical energy. Okay, electrical energy to chemical energy. So you have your battery, and the positive terminal is called what, Marcus?
Anode.
This is your
Anode.
and this is your
Cathode.
cathode. Positive terminal is anode, negative terminal is cathode. Now, basic electrolysis, what happened when, say, I electrolyze molten okay, we have molten PbCl2, molten lead chloride. Remember, molten and aqueous. The difference is aqueous is you add to water, it dissolves. That is an aqueous solution. Molten means you heat it up, it turns from solid to liquid. That is molten. So molten PgCl2, you electrolyze it. What ions are present, Melissa? What ions are present? Marcus, what ions?
Pb2 plus.
Pb2 plus, what else?
Cl minus.
Cl minus, right. Okay, now, so which one goes to your anode? Which one goes to the anode? Pb2 plus or Cl minus?
Cl minus.
Cl minus,
Cl
right.
minus go to anode.
We have Cl minus. Now, what happened to Cl minus? Losing or gaining of electrons?
Losing.
Losing electrons from what?
Cl2.
So
So equation. Okay, Melissa, pay attention here. You have two atoms, Melissa. So two atoms has to come from what? Two ions.
Ions.
One electron, two ions, two electron. Oxidation or reduction? Is this oxidation or reduction?
Oxidation.
Oxidation, right. Okay, now, so this electron will travel from anode to cathode, right? So remember, electron always travel on the external circuit. So the electron travels from anode to cathode, right? What goes to your cathode? Cathode is the negative terminal. So what
lead.
goes to Pb2
Pb2 plus.
plus. So what happened to Pb2 plus?
It gains
It gains
electron.
two electrons to become Pb.
Pb. Sorry.
Oxidation or reduction?
It's reduction.
Reduction.
This is reduction.
Reduction.
Right. Okay. So your full equation. So at the anode you have losing of electron. At the anode you have oxidation. At the cathode you have reduction. What's your observation? At the anode you see greenish, yellowish green gas. At the cathode you have apa? Gray deposit of that. Right. Now, if I give you molten sodium chloride, what do you get? Now change this into molten sodium chloride. What ions are present again?
Sodium and chloride.
Plus and Cl minus. Okay. And A plus, Cl minus will go to?
To the anode.
Goes to anode.
Then what happened to Cl minus?
It undergoes oxidation.
Okay, give me the equation.
To Cl minus.
Right. Okay. And A will go to, and A plus will go to your cathode. Right. So you have Na plus electron to give you Na. Right. Okay. Now, once you understand this, tell me what is electrolysis then? What is electrolysis? Tadi you have lead chloride, lead-2 chloride. You're going to get lead and chlorine. And then you have molten sodium chloride. You're going to get sodium and chlorine. Last class, do electrolysis of apa? Electrolysis of oxide. Remember? We discussed about extraction of aluminium and electrolysis of oxide. Right. What happened, I mean? Electrolysis of oxide? What goes to your anode? What goes to your cathode?
Electrolysis of oxide,
Yep. Remember, this is molten
molten aluminium oxide
cryo
in cryolite.
discussion. Right. Now, what ions are present?
There is Al3 plus,
We have Al3 plus,
O2 minus.
O2 minus. Now, what goes to your cathode?
The cathode, the Al3 plus is attracted to the cathode.
It goes to your cathode. What happened?
It's reduced to aluminium by gaining 3 electrons.
O2 minus will go to your
O2 minus will go to the anode.
anode. So what happened?
and oxidize by by donating or losing 2 electrons to become oxygen gas.
Now, I'm assuming that all of you are okay with the ionic equation here. If you don't know what's going on here, just stop me, okay? Now, siapa tadi? Now, so here you have molten aluminum oxide, you get aluminium and oxygen. Okay, now if I give you lead chloride, okay, lead chloride, you have lead, chlorine, you get chlorine, you get lead, right? If I give you molten sodium chloride, you're going to get sodium and chlorine. So now, based on these three examples, what is electrolysis? What is electrolysis? Anyone? If you have molten aluminum chloride, you get aluminum oxide, you get aluminum and oxygen. If you have molten sodium chloride, you get sodium and chlorine. If you have molten lead chloride, you're going to get lead and chlorine. If I give you molten magnesium oxide, what do you get? What do you get? Someone? What do you get? I mean, what do you get?
Yes.
Molten magnesium oxide, you're going to get?
Molten magnesium oxide, we're going to get magnesium, metal, and oxygen gas.
Right. If I give you molten silver chloride,
Molten silver chloride will have deposit of silver and chlorine gas.
chlorine gas. Right. Okay. Now tell me, what is electrolysis?
Electrolysis is the
Balkis, what is electrolysis, Balkis?
Electrolysis, the
From the example that we what is electrolysis? Molten lead chloride, you get lead and chlorine. Molten aluminum oxide, you get aluminum and oxygen. Molten apa lagi? Silver chloride, you get silver and chlorine. So from that example, what is electrolysis? Nina, what is electrolysis, huh?
The breaking up of compound to form metal and gas.
Breaking up of compound to form metal and gas. Does it necessarily be gas?
No.
No. Okay, tadi nah, take a deep breath nah. Aluminium oxide, kita dapat aluminium and oxygen. Lead chloride and chlorine.
Yes.
What is electrolysis? What is all this? What kind of compound is aluminum oxide? What kind of compound is lead chloride? What kind of compound is silver chloride? What kind of compound is that? Nina, what kind of compound is that? I mean, what kind of compound is that?
Ionic compound.
Ionic compound, right? Ionic compound made up of what element? I mean, aluminum oxide. What element made up aluminum oxide?
Aluminium oxide, aluminium and oxygen.
Aluminum and oxygen. So if you electrolyze molten aluminum oxide, you get back aluminum and oxygen. You electrolyze molten sodium chloride, you get back sodium and chlorine. Are you following me here? So if I ask what is electrolysis, you add on from what Nina said just now?
Breaking of ionic compound into elements.
Or is it separating?
Separating, sorry.
The separation method. Separating
separating
ionic compound into
elements.
covalent compound.
Is covalent
Into its
ada ion tak, Markis?
Yes, tak
Covalent
dengar.
ada ion tak? Covalent compound ada ion tak?
Ada?
Covalent
Oh,
compound.
covalent. Oh, covalent. Tadi.
Okay, again. So what is electrolysis?
The separating of ionic compound to form
Okay, take a deep breath. Aluminium oxide. You dapat aluminium and oxygen. Sodium chloride, you get sodium and chlorine. So separating ionic compound into apa?
Into its elements.
Element, because aluminium oxide are made up of what element? Aluminium and oxygen. Sodium chloride is made up of sodium and chlorine, right?
chlorine.
So you get that, you have to understand that. Don't try to memorize it. You have to understand. Look at the example, then you see that it's all about getting back the element from its ionic compound. How do you get back elements from its ionic compound? By means of electrolysis. So what is electrolysis? Again, Nina?
Separating of compound into its elements.
Ionic
Separating ionic compound to
compound
form its element.
into its
Elements.
into its element by using what?
By using electricity.
Yes, by use of electricity. Because they do ask you what is electrolysis. They give you 2 marks. So don't throw away just because you don't get the hang of it. So remember, if you remember this, you will remember. If you understand this, it's easy for you to remember. Aluminium oxide, you get back aluminium and oxygen. Sodium chloride, you get back sodium and chlorine. So what is electrolysis? It's a separation method. Separating what? What kind of compound? Separating ionic compound into element. By means of what? Electricity. From now onwards, whenever you see the battery sign, you know you have to treat it as electrolysis. What happened during electrolysis? You have anode. So what happened, if I ask you what happened during electrolysis, you have your N ion will get attracted to the anode and then release electron, and this is oxidation, right? Now, what happened next? Electron travels from the anode to the cathode, right? What else you have to remember about electrolysis? Cation is cation, which is a positive ion, right? Okay, cation will gain electron. Okay, it will be attracted to the cathode and gain electron. Oops, sorry. Okay, so remember what happened during electrolysis. Electrolysis, anion get attracted to the anode. Okay, cation get attracted to the cathode. And then what happened to the cation? It gains electron. So this is what?
Reduction.
So now you get that? Yes or no? So 3 things. An ion goes to anode, it releases electron. So therefore, oxidation happens at the anode. Electron always travel from anode to cathode. Cation get attracted to the cathode and it gains electron, hence its reduction. So past paper, they can give you electrolysis is a redox reaction. Using suitable example, explain. So how do you explain? You can just take any of the example. Get it? Understand? Yes? You okay?
Yep.
Okay, now.
Yes.
So now next are factors affecting electrolysis. Okay. You remember 3 things happen during electrolysis. What are the 3 things again? What are the three things taking place during electrolysis? Anion goes to
Anion goes to anode.
anode, and then it releases
It
electron.
releases
Undergo
electron.
oxidation.
Undergoes oxidation.
Cation is the
Cation attracts to cathode
method.
and gains electron, but undergoes reduction
Electron travels
from
anode to cathode.
anode to cathode.
Those three things. What is electrolysis?
To separate ionic compounds to its own element by electricity.
Using
Electricity.
right? So now, what are factors affecting electrolysis? Okay, the first factor will be your reactivity series. Right. Okay, if I electrolyze molten sodium chloride, okay, I electrolyze molten sodium chloride. What ions are present? Na
Sodium and
minus. What goes to anode?
chloride.
Give me
Chloride
the
ion goes to Cl minus E equals to Cl2.
minus berapa
E2.
to give you
Cl2.
what happened at the cathode?
Undergoes reduction.
Right. Okay. Now, but if I give you aqueous, sodium chloride aqueous. Remember what did I say just now? Molten means you heat it up, it melts. Aqueous means you add water and it dissolves. Now I have sodium chloride aqueous, right? What ions are present in aqueous sodium chloride? I mean,
Aqueous sodium chloride. Sodium chloride. So Na plus, Cl minus, OH minus, and H plus.
okay, you have Na plus, Cl minus, H plus, and OH plus. Okay, now, so what goes to anode now? What goes to anode? You have a choice of? Nina, you have a choice of?
Yes, teacher. The Cn minus and OH negative.
Okay, which one will be chosen? Okay, in terms of when you come to the factors of reactivity series, remember when of ions, the least reactive, okay? So the least reactive will be chosen. And if you have an ion, hydroxide is the least reactive. When you talk about metal reactivity or metal that we did last week, sodium, potassium, and all those things, right? Okay, potassium, sodium, calcium, all those things. Okay, get it? So if you have choices of ions, if you have molten, you don't have choices of ion. Like I give you molten sodium chloride, you only have sodium and chloride ion. No choice. So which one will be chosen? At the
OH negative.
anode will be chloride
OH
ion,
negative.
and at the cathode you have sodium ion. But if you have aqueous sodium chloride, you have a choice of Na plus, Cl minus, H plus, and OH minus. So what will be chosen at the anode? You have to choose OH minus.
OH minus.
OH minus is less reactive than chloride ion. So what's your equation here, Balkis? Okay, losing or gaining of electron? Losing? Losing or gaining? Tell me that first.
It's gaining electron.
Balkis, this is
Yes.
then ion goes to anode. Does it lose electron or gain electron?
Loses electron.
Loses electron. To form,
So to form oxygen and hydrogen. So
to form oxygen and
H2O, hydrogen.
water. Okay, oxygen and water. Now, balance the equation. You have 2 here, you put 2 here.
2,
So
2
you have
H2,
2, 2, 4,
4 OH.
you have 4. 1 OH minus 1 electron, 4 OH minus 4 electron.
4 electrons.
Oxidation or reduction?
It's oxidation.
It's oxidation. Why oxidation?
It loses electrons.
Loses electrons. So hydroxide will be oxidized to oxygen and water. Now electron travels from anode to cathode. At the cathode, what happened? You have a choice of sodium ion and hydrogen ion. Okay, now the rule of thumb is the less reactive ion will be discharged. So which one is less reactive? Okay, sodium ion, sodium and hydrogen, which one is less reactive?
Hydrogen.
Hydrogen. So what happened here?
H plus.
Right, you see bubbles of hydrogen.
Bubbles of
Addition or
hydrogen.
reduction?
It's reduction.
It's reduction. Right, okay. So now what happened to the solution? The solution just now is aqueous sodium chloride. What happened to it now? What happened to it? You take out what? You take out H plus, you take away H plus, you take away OH minus. So it turns into concentrated sodium chloride.
Concentrated sodium chloride.
Understand? Now, the same case here, this is passe paper. It says sodium hydroxide is manufactured by electrolysis of brine, concentrated brine. Okay, this is 4 marks question, passe paper. It says electrolysis of concentrated brine will give you sodium hydroxide. Now they ask you to explain. Do you know what brine is in the first place? Melissa, do you know what brine is?
No.
No. Muhammad, do you know what brine is? This is Muhammad apa? Amar. Do you know
Yes.
what brine is?
Yes.
Do you know what brine is? B-R-I-N-E.
No.
No. Okay. Sorry, I don't get your full name. Ahmad tak bagi. Muhammad, what? How do I address you?
Amirul, I'm Muhammad Amirul.
Amirul. Okay, Amirul, have you joined us before?
Huh?
Have you joined us before?
Yes.
Yes, you have. Okay, okay, Amirul, do you know what brine is?
No.
No. Okay, brine is sodium chloride. Okay, brine is sodium chloride. Okay, this is passive paper, Amirul. It says here that sodium hydroxide is manufactured from concentrated brine. And they ask you to explain how it's being done. They give you 5 marks. Okay. So what you do is that you mention concentrated brine. Okay. So inside you have what? You have sodium ion,
Sodium.
hydroxide ion. Sorry, concentrated brine. Sorry, brine is sodium chloride. Okay. Sodium chloride. So you have Na plus, Cl minus, and even though it's concentrated, there still is some water there. So you have H plus and OH minus. Now, so to do this, you have to go back to the second factor. First factor just now is reactivity series. So the least reactive will be discharged, right? So that's the first factor. Second factor is the more concentrated one. So the factors of
concentration.
Right. So the more concentrated one will be chosen. Right. Okay. The more concentrated ion will be chosen. So now, if you have this, okay, passive paper, they said concentrated brine. The concentrated brine is sodium chloride. Concentrated sodium chloride. Just now, you do sodium chloride, but dilute sodium chloride. So when you have sodium chloride, you have sodium ion, chloride ion, H plus and OH minus. So what will be chosen at the anode will be hydroxide ion, hence you get your oxygen. What you get at your cathode is hydrogen ion, hence you have your hydrogen. You choose hydrogen instead of sodium because hydrogen is less reactive than sodium. You choose hydroxide because hydroxide is less reactive than chloride ion. But now what if you have concentrated brine? So if you have concentrated brine, you have sodium ion, chloride ion, hydrogen ion, and hydroxide ion. But now this time it's concentrated. So what goes to your anode? Okay, what goes to your anode is still H plus and Cl minus, right? Sorry, OH minus and Cl minus. Now, this is concentrated. Concentration of chloride is much more than concentration of hydroxide. Okay, so because concentration of chloride is more than hydroxide, chloride will be chosen instead. So you'll be getting Cl minus 2 electron to become Cl2. You see bubbles of yellowish gas at the anode. Okay. Now at the cathode, we have a choice of sodium ion and hydrogen ion. So bear in mind, sodium is highly reactive. And when we did last class, right? From last class, when we talk about reactivity series, those that are highly reactive, okay, they have a greater tendency to lose electron. They are more stable in ionic form. So it's quite difficult to discharge them. So given the choice between sodium and hydrogen, hydrogen is less reactive than sodium, so hydrogen will be discharged. Okay. So you get hydrogen. So now, coming back to your solution just now, you have sodium ion, chloride ion, hydrogen, and hydroxide. You discharge, chloride will be discharged, hydrogen will be discharged. You are left with sodium, a solution of sodium hydroxide. Get it? You end up with a solution of sodium hydroxide. Are you clear? Yes? No?
Yes.
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 This is 4 marks question. Balkis, explain again. How do they manufacture sodium hydroxide from brine?
Okay, there's at anode there will be chloride ion and hydroxide ion, and the least reactive will be discharged. So at the cathode there will be sodium ion and also hydroxide ion, and hydroxide ion will be discharged, undergoes reduction, giving 2H plus 2E, giving 2H2 electron, and then yang anode tu saya tak berapa clear ke anode.
Goes to the cathode, Balkis?
Yes,
What goes to the cathode? What ion goes to the cathode?
H plus,
H plus and?
Na plus.
Okay, which one will be discharged?
H plus will be discharged,
Why?
giving 2H2, because it's the least reactive.
Okay, and the anode, what choice do you have?
Chloride and also hydroxide.
Which one will be chosen?
Hydroxide.
This is concentrated. What?
Oh, yeah. Chloride ion will be discharged, undergoes oxidation, so it will give yellowish gas.
What is the name for that yellowish gas?
Chloride.
Chloride?
Chlorine. Chlorine.
So the solution changes from concentrated brine to?
Yellowish gas.
The solution changes from concentrated brine to?
Sodium hydroxide.
Sodium
Sodium
hydroxide.
hydroxide.
Because you discharge hydrogen, you discharge chloride, so it changes from concentrated brine to sodium
Sodium hydroxide.
Get that?
Yeah.
Same case as if you do dilute hydrochloric acid and concentrated hydrochloric acid. Okay, dilute HCl. Both will have what? Dilute, concentrated, both will have H plus, Cl minus, OH minus, right? But which one will be discharged at the cathode? F2H plus 2 electron give you H2.
H2.
If you talk about dilute HCl, which one will be discharged? OH minus or Cl minus?
OH minus.
OH minus, because OH minus is less reactive than chlorine.
Correct.
Chlorine.
So therefore you have 4 OH minus 4 electron to give you 2 H2O plus O2. But if you do concentrated HCl, what do you get? Do you still get oxygen?
No.
No, what do you get?
Chlorine gas.
You get chlorine, because now concentration of chloride is much more than hydroxide, right? So therefore, what happened when you do concentrated HCl? You get 2Cl get 2Cl minus electron to become Cl2. See the difference here? Right. Faham tak? Everyone okay with this? Yes? No?
Yes.
Lisa, do you get it?
Yes.
So because the first factor, you have to understand that the first factor is reactivity series. You
That is
discard
reactive.
those
That is
that
reactive.
is less reactive. The second factor is concentration. So for the second factor, even though the less reactive is, even though the less, even though it's less reactive, even though it's more reactive, but it's more concentrated, then you choose that. Like chloride, even though chloride, normally chloride is not chosen, now chloride is chosen because concentration of chloride is more than hydroxide. Okay. Now the third factors will be type of electrodes. Okay, when you talk about type of electrodes, remember what are electrodes just now? Electrodes are made up of metal or graphite, right? It can be platinum, it can be carbon, or it can be any metal so long as it conduct electricity. Now, say you do electrolysis of aqueous copper 2 sulfate, okay, using graphite electrodes. Okay, using graphite electrodes. Okay, copper 2 sulfate. What ions are present? What ions are present? Cu,
Cu2 plus. As opposed to negative. H plus and OH minus.
okay, now what goes to your anode?
As opposed to negative and OH minus.
Okay, which one will be chosen? Which one will be chosen?
OH minus.
Minus. Why you choose OH minus? Because
Because it's
Reactive.
it's less reactive. Or 2 minus, right? So what do you get there? You have 4 OH minus to give you 2 H2O plus O2, right? So you see bubbles of oxygen at your anode. Electron travels from anode to cathode. Now at the cathode, what happened? You have a choice of Cu2 plus and you have a choice of H plus. Which one will be chosen, Balkis?
Yes. Cu2 plus and H plus. This one is aqueous. So it's H plus.
Nina, which one will be chosen?
H plus.
Huh? H plus? Take a deep breath, Nina. Which one will be chosen?
Sorry.
Copper, Nina, copper.
Yeah, copper.
Copper. Okay, copper will be chosen. Kenapa, Nina? Sebab copper is less reactive than hydrogen.
That's one. Very.
So you have Cu2 plus 2 electron to become copper, right? So you see brown deposit of copper. So if they ask you what is your observation, bubbles of colorless gas at the anode, and you have brown deposit of copper at the cathode. Now remember, anything aqueous with Cu2 plus will be blue in color. Now what happened to the color? What happened to the blue color? What happened to the blue color?
The blue
Turns to
color
colorless.
is colorless.
It turns colorless. Why does it turn colorless? Why
Because
does
all the
Copper to
Cu2
plus
plus
is reduced
ions
to
have been
copper.
discharged,
it been reduced to copper?
reduce the copper.
Okay, copper 2 ions has been reduced to copper. So therefore, the solution changes from blue to colorless. They do ask you the observation. Now, this is when you use graphite. But if you perform the same thing, but you use, say, okay, you do copper electrodes instead. Okay, you have CuSO4 aqueous, and then you have copper electrodes. What happened at your anode?
The anode dissolves.
Remember, this one, just now when you do it, you are using graphite. Now you are using copper. So this is one concept. Remember, metal in its aqueous solution. Copper in copper 2 sulfate, zinc in zinc nitrate, silver in silver nitrate, tin in, okay, whenever you have metal in its aqueous solution. Anode will corrode, cathode will be deposited. Make it your mantra until you remember, okay, because the application of it is a lot. So you have copper in copper 2 sulfate, okay, anode, corrode, cathode, deposited. So remember that. What does it mean? It means that here at the anode, remember the anode is made up of copper, cathode is made up of copper. So what happened is that copper, Cu, minus 2 electron to become Cu, okay, 2 plus. So copper ion, the copper loses 2 electron to become Cu2 plus. So copper atom will be oxidized to copper ions. So what your observation would be the copper, the electrode will get thinner, the electrode will corrode. The mass of the electrode decreases. If they ask you what is your observation, anode corrodes or mass of copper decreases, okay, or copper anode get thinner, anything of something the same as that, okay, it means the same thing. So now electron travels from anode to cathode. Now at the cathode, what happened? Cu2 plus copper ion plus 2 electron to become copper. So copper ion is copper. So what's your observation? You have brown deposit of copper.
Solid.
Now, what is another observation here? If your observation, if you use graphite, what's your observation? You have colorless gas at the anode, and then you have brown deposit of copper at the cathode, and the electrolyte turn from blue to colorless. But if you use copper electrode, copper 2 sulfate and copper electrodes, and your cathode will be brown deposit of copper. What about the color of the solution?
It remains the
Remains
same.
blue.
Remains blue.
Blue. Why does it remain blue, Balkis?
There's still a copper ion.
I mean, why does it remain blue?
The rate of the rate of reduction of copper ions to copper atoms is the same as the rate of copper atoms oxidizing to become copper ions.
Okay, okay. So here, why does it remain blue? Because the rate, remember I used the word the rate of oxidation of copper atom into copper ions equals to the rate of reduction of copper ions into copper. So there is no change in the number of copper ions in the solution. That's the reason why the solution remain blue. Get it? Understand? Okay, because the rate of oxidation of copper atom into copper ions equals to the rate of reduction of copper ions into copper. Okay, if to make it clear to you, say you have 100 ringgit, right? You have 100 ringgit, and then your mom give you 100 ringgit to spend. So you use the 100 ringgit that your mom give you to buy things. So your 100 ringgit is still there. It doesn't change. You still have your 100 ringgit. So the same case here. Okay. At the anode, copper atom is oxidized to copper ion. At the cathode, copper ions is reduced to copper. So you don't change the number of copper to sulfate in the solution. That's why the copper, the blue color remain blue. Okay. Now, but in this case, if you use graphite, what happened? It changes from blue to color.
Blue to colorless.
The reason is because the number of copper 2 ion decreases. What happened to the copper 2 ion? What happened to the copper 2 ion, Balkis?
It loses
It
electrons.
has been reduced to copper at
Copper atom.
Okay, now everyone okay with this? Yes? The application of it. From now onwards, you have to remember, when you have metal in its aqueous solution, anode will corrode, cathode will be deposited. So you can replace this. Once you understand that concept, it's very, very easy. You can put zinc okay, you can put zinc in anything, zinc nitrate, aqueous, right? You can put silver in silver nitrate aqueous, anything. So what happened at the anode? What happened at the anode, Melissa? Amirul, what happened at the anode?
Mm. Mm.
Look at what happened to copper just now. That will give you a clue. What happened to the copper anode? It will be oxidized to copper ions. Why? Because it's copper in aqueous solution of copper to sulfate. Now, with that understanding, you go to zinc. Zinc is zinc nitrate. So what happened to anode? Zinc will be oxidized.
Zinc ion.
Zinc ions.
So what's the observation? Zinc anode will corrode. The mass decreases or anything similar to that. What happened in the cathode now? Like N2 plus 2 electron to become
And
deposited.
deposited
You
at
can
the
replace
cathode.
this again with silver and silver nitrate. So sama juga. This has to be anode will be silver minus electron to give you silver ion. And here should be silver ion plus electron to give you silver. Right. Or you can replace this with anything. You can replace with Pb and NO3. Right. So here, what happened here? Pb minus 2 electron to become Pb2 plus. Here what happened? Pb2 plus 2 electron to become Pb. So it's still the same concept. Understand the concept. When you have metal in its aqueous solution, anode corrode, cathode deposited. Okay. Now, once you understand this, then only you know what's the application of electrolysis. Okay, you know already one application of electrolysis is extraction of metal. You can do electrolysis, you can apply electrolysis for electroplating.